Last week I was messing around with some math, graphing some basic functions, and I started wondering if it was possible to use pure equations to actually draw stuff. I started simple, a few circle equations, some restricted bounds, and I had a basic smiley face. Then I looked for something a bit more complex. Like if you type in x squared plus y squared minus 1 all cubed minus x squared y cubed equals 0, the graph snaps into this nice hard shape. I kept on digging to see how far I could push this. Now I found polar equations that use the golden ratio to plot points, and it actually generates a nice sunflower pattern. However, if you change that 137.5-degree angle to literally anything else, the spiral completely breaks apart and the pattern just disappears. That is a math rabbit hole on its own. Anyways, it looked awesome. But I realized I was hitting a hard limit. These are just lines and dots on a background. If I wanted to draw something cinematic, like a fully lit three-dimensional black hole, I couldn't just trace an outline. Line math wasn't going to work here. I had to change how I was rendering things. Instead of drawing a line from point A to point B, I wrote a Python script. The script looks at every single pixel on the screen and runs a massive equation to figure out exactly what color that specific pixel should be. And that's what I spent the rest of the week doing, trying to draw a visually convincing black hole from scratch, piece by piece, using pure math. The first piece for this project was the black hole void. I first needed something to cut a hole into. I started by generating a massive field of glowing plasma. By running the grid coordinates through an exponential decay function and mapping it to a warm color scale, the screen fills with a bright fuzzy orange light. Then came the event horizon. I needed to punch a hole straight through the center of that orange glow using an equation that acts like a sheer mathematical cliff. So I used a hyperbolic tangent function. Now I set the radius to 1.0, even though at a value of 0.2 it is already steep enough. And the math forces anything inside that boundary to multiply by 0. Now the center of that gas drops instantly to absolute black, leaving a perfect pitch black void. Now for the accretion disk, I took a basic distance formula and squashed it on the y-axis. By multiplying the y-coordinate by a heavy squash factor, a perfect circle flattens out into this nice horizontal plane cutting across the void. A visually convincing black hole bends the light behind it, so I had to create a dynamic lensing profile to force the back of the disk to physically arc over the top. Now I left the bottom part for artistic reasons, but I would definitely share it at the end of the video. This took a lot of trial and error to get the geometry right. If you tweak this lensing variable, you can change how violently the gravity pulls the light. I intentionally adjusted it a bit low so you can actually see the distinct slit of negative space between the front and the back halo. At this point, I wanted to add some glow, and to do that, I layered an exponential core bloom over the math. This softens that hard geometry. It calculates a dense, bright core and then adds this wide, soft exponential decay on top of it. It gives the ring that massive glowing atmospheric bleed. At this point, I could say the black hole itself was finally working, but the background was completely empty. I needed a nebula. So I wrote a loop that multiplies sine and cosine waves together to simulate cosmic dust. But the math literally just drew a plaid shirt. It was a repeating rigid checkerboard grid. And to fix it, I fed the cosine wave directly into the sine wave. Evaluating cosine as the input for sine fundamentally shatters the linear grid. Now it turns the rigid math into this fluid organic smoke, which definitely, well, looks good. It's not perfect, but it looks good. Then I dropped a star field behind it, because what good is space without stars? The equation for that is just a massive matrix of random numbers that filters out anything below a certain threshold. Most of the pixels go black, and the tiny fraction that survives, they become stars. Finally, I wanted that massive gravitational lensing effect. Gravity doesn't just bend the accretion disk, it bends the entire universe behind it. So I wrote a spatial inverse square warp that physically grabs the coordinates of the stars and the nebula and sucks them towards the event horizon. I wasn't trying to rigorously simulate Einstein's field equations, but I wanted an effect that was visually convincing, and it works perfectly in this case. You can literally see the stars and the nebula stretching into streaks as you get closer towards the void. Eventually, all of it collapsed into one massive composition of functions. But looking at a static image wasn't enough for me. I created some variable changes to build a simple forming animation, bringing it all together piece by piece and then transitioning into this seamless loop animation at the very end. Now, I hope you guys like it. Anyways, thanks for watching, and I will see you in the next one.